Hi all, welcome to the second soil profile that we're going to be looking at as part of the biosphere topic, and in today's video we're going to be looking at a brown earth soil. Now, as with the Podzol video, we're really just going to focus on this slide today, as it gives us our outline of the main processes and characteristics involved in identifying and the creation and maintenance of brown earth soils. So first, where do we find brown earth soils? Now, we find these largely in areas where we've got precipitation in excess of evapotranspiration. So again, we've got a fair amount of precipitation going on here. We've got fairly moderate temperatures. It's not particularly extreme. It's not particularly swingy in terms of where the temperatures are. But the big difference that we have is the vegetation cover that we've got. We're talking about deciduous woodland primarily, and this is very, very important because it means that we are going to get very, very rich leaf fall every autumn. And as it mentions in the slide here, that this is often replaced with agricultural land, primarily because brown earth soils make very, very fertile soils. So, given that we've got these areas where we've got a fair amount of precipitation, some fairly moderate temperatures and a lot of deciduous tree cover, what does that mean for our soil? So first, our leaf litter. We've got very, very thick leaf litter, obviously particularly in the autumn months when the trees shed, but we are also talking about, throughout the year, just different bits and bobs of material that comes off the trees and the undergrowth that we have. Now, because we have got a fair amount of water, and we've got reasonably high temperatures, that means we see decomposition happen pretty rapidly. We've also got a lot of soil biota. We've got a lot of things alive in the soil, and these drive this decomposition and humification processes very, very quickly. Now, we do get a very, very thick O horizon. We do tend to find a very, very thick mull humus as well, which is normally fairly alkali, and that means that it's going to be quite good for growing things. As I mentioned earlier, brown earth soils are typically pretty fertile. Now, if we start to go through our horizons, now our A horizon, right, it's got a kind of crumb, sandy structure to it. You might have some kind of streaking or staining as material moves throughout it. You have some leaching in brown earth soils because we do have precipitation in excess of evapotranspiration, but it's nowhere near as pronounced as we have in podzols. But one of the big things that we notice here is that we've got a very rich reddish brown colour, and that is throughout the entirety of the A horizon, and that colour gradually fades out and gradually becomes paler as we move right down to the bottom of the B horizon. But one of the big distinguishing factors of brown earth soils is that we don't have particularly clear horizons. It's not like with a podzol where you've got a nice, neat iron pan and say, right, that is my transition point from my A horizon to my B horizon. You don't have that in brown earths. Some of the reasons we don't have that, as we've said already, leaching is not as pronounced as it is in podzols, although it is still a factor. But the big thing here, to come back to them, is that soil biota, particularly, earthworms, different insects, moles, all of these things live in the soil, they burrow, and in the process of doing that, they move the soil around and they get rid of those nice kind of transitional boundary markers. So, as I say, we've obviously got elevation and elevation, as we have discussed, because leaching is still a factor, so we do still have different minerals that are being moved from the A horizon down into the B horizon, but it's not as pronounced a factor as it is with podzols, as I've already stated. It does mean that as we go down, the B horizons are slightly more clay-rich, and they do have some kind of excesses of maybe iron and aluminium minerals, but it's not hugely pronounced. One of the last points that we actually bring in here, two of the last points. One is the nutrients that we've been talking about. We do see a lot of these nutrients come back up to the upper B and A horizons through recycling by plants. This is again where these deciduous plants are extremely important here, because deciduous plants, particularly deciduous trees, or large deciduous trees, have deep expansive root systems. This can do a lot of biological weathering, and it can bring a lot of movement of nutrients back to the upper horizons. Now, these roots can also go down into the sea horizon and start to break up the bedrock. They can start to break up that parent material. Now, what the big impact of that is the more it's broken up, the more subject to different forms of weathering it will be, and that then means that the entire soil will drain more freely, unless this was particularly clay-rich, which they tend not to be. These are soils that drain very, very regularly, and that helps to promote their fertility as well, because it means you don't have waterlogging or some of the different processes that could hinder fertility. Now, I'm going to draw this one to an end here, guys. We've got one more soil profile that we're going to look at, and that will be in the next video, and that's looking at tundra glaze. And I'll see you guys then. Bye.